Hello everyone. In today's video, I will be going over my notes over domain and range. This is a very important concept. I cannot stress how important it is in Algebra 2, and then if you plan to study math past Algebra 2, it's going to keep coming up, and it's something that's expected of you at that point. So it's really something we need to take time with and make sure we understand. So I'm going to go through these definitions kind of quickly. So if you want to write this down first, go ahead and pause the video, and then that way you can listen. So domain, it is just your range of x values, and then range is the range of y values. So the thing to remember is that domain goes with x and range goes with y. It's a very generic definition, but the meat of it is how we write it, and you're going to understand this better when we start looking at some examples. Interval notation, this is what we use to write our domain and range for a graph or for a set of numbers. So we've got two types of notation. We have the brackets and the parentheses. The brackets, we use them when a number is included. And when it's included on a graph, this looks like a closed dot. So if it's included, you use the bracket. Parentheses, use when a number is not included. So on a graph, this looks like an open dot. One big piece of information here. You always use parentheses when you have negative infinity or positive infinity in your domain or range. We do this because the infinity symbol is just a symbol. It's not actually a number. There really isn't a largest number. The numbers keep going. But we as people can only understand so far. From there, we just call it infinity, and that's just how we understand it. All right, let's look at some examples. First, we have a domain here, and our interval is -2 to 6 with brackets. So what this means, since this is domain, we're looking at the x values. This interval is all x values from -2 to +6. Now we have to think about the brackets. -2 and 6 are included in this interval. So it's not just the numbers between -2 and 6, but including -2 and 6. And again, that's because it's written with brackets. Our range is -10 to 2. So this is going to be y values, all y values from -10 to +2. Now, since we have parentheses, -10 and +2 are not included because we have parentheses. So this interval means it's just the numbers between -10 and 2, but it doesn't include them themselves. Let's look at another example. Example 2. Our domain is -7 to 4. So again, domain, we're working with the x values. This is all x values from -7 to +4. Now, before I reveal the next part, notice we have a mixture of symbols. We have one parenthesis, one bracket. This is 100% possible. Something we can also have. So we have one of each. This means -7, since it has the parenthesis, is not included, but 4 is included because of the bracket. So this is all the numbers after after -7, not including -7, all the way up to and including +4. Range. This range is 7 to infinity. This is the type of domain and range that you're going to get used to seeing in this class, where you have an infinity in one of the spots. Very common. Range, again, these are y values. So this is all y values from 7 to infinity. And then since 7 has a bracket, 7 is included. So we can say that this is 7 and up. Now, if this was not included, then it would just be all the numbers bigger than 7. So it wouldn't include the 7. But since we have a bracket, 7 is included. I've got one more example. Domain. This is a very common domain, probably the most common one you're going to see in this class. A reminder though, your domain is not always negative infinity to infinity. A lot of students, they will assume that. It's not always the case. Most of the time, yes, but always, no. Really think about it before you put this down. How we read this, read it directly, negative infinity to infinity, but what it means, all possible x values, every single one, works. And the other way to say this is a very common expression in just math in general, in the math community, is all real numbers. Range, I use the same one. So it's going to be the exact same thing except with the y values. All possible y values. Another way to say this is all real numbers. All right, that covers definitions and notation, and then just a few examples of interpreting what this means when you see it written with just the numbers and the parentheses and the brackets. Now let's look at some graphs. Now, given a graph, we have to figure out what the domain and range is. So we have to figure out the numbers that we're going to include, and then how we're going to write the notation. Are we going to use brackets, parentheses, that kind of thing? Before I dive in, something I want to point out here. These axes, first off, they do have arrows. I just cut them off for space. If we followed these arrows, where would they end up? So starting with the negative numbers on the x-axis. If I keep going negative, I'll end up with negative 10, negative 100, negative 1,000, negative 1,000,000. This is going to just keep getting more and more negative. So we say that this heads towards negative infinity. And then the positive side is going to keep getting bigger and more positive. So it heads towards positive infinity. On the y-axis, if we go up, we're getting bigger. We're heading towards positive infinity. And then if we go down, we're getting more negative. So this leads to negative infinity. We aren't going to use this on this problem. We will use it in a few problems from now. So I just wanted to go ahead and point it out as just something to be aware of. And you might want to practice this by every time marking your graph until you get the hang of the directions. It's very easy to write a positive infinity when you mean to say negative infinity and vice versa. So for this problem, we're going to find domain and range. So for the domain, a few reminders as I write this. When we look for the domain, we go from left to right. That's the direction we follow. And this is important. If you go the wrong way, you're going to get the wrong answer. Reminder, domain is the x values. When we're doing this, I like to explain it as if we're scanning the graph for these things. So when we move from left to right, we're going to start on the leftmost side of the graph. So that's over here. And what I'm going to do is I'm going to move this post-it and cover up the graph, and I'm just going to see what happens. So I'm looking for a starting point. And again, we're focusing on x values here. That's why the post-it note. The less of the graph you focus on at a time, the better. When you're trying to look at it all at once, a lot of students get confused. But when I'm moving left to right, you can see I'm moving along the x-axis. And eventually the y-axis completely disappears. I don't even want to look at it. I don't care what the y-axis is doing right now. So over here, there is absolutely no graph. It is just the coordinate plane. No graph on it, no line, no points, nothing. So we have nothing right now. And I keep going until I hit my first point, which is right here at positive 3 on the x-axis. So that's going to be the first number in my domain, is positive 3. And notice there is a point with the 3. It's right here. That's a closed point, a closed dot. So we're going to use a bracket. 3 is included in this domain, comma. Then I'm going to follow the graph and see what happens. So as I move to the right, this stays nice and filled in is the best way to say it. It's just a line. It keeps going. It doesn't stop. It doesn't break. There are no holes in the graph. And what I mean by hole, I'll go ahead and show you on number 2. That's a hole. You don't want a hole. You want all of them filled in. You want a continuous line. So if we keep going, it's still continuous. There's no breaks, no jumps, no holes. Keep going, and it stops right here at this point. This point is at 11 on the x-axis. And notice it is a filled in circle. So once again, we're going to use the bracket here. So my full domain is from positive 3 to 11. That's where the graph is at on the x, in regards to the x-axis, the x values. It doesn't just include the parts that are actually crossed by the line on the x-axis. We're talking all of it. So again, we're looking at just the x values. Now let's look at range. Reminder, range is your y values. So I'm going to look at the y-axis here. Range, the direction is from bottom to top. So you want to start at the bottom of the graph and work your way up. Again, if you go the wrong way, you're probably going to get a wrong answer. So this time we're going to start at the bottom of the graph. And we're going to move this upward. Now I'm looking at the y-axis, not the x-axis, just the y-axis. And again, as the more I move, eventually this is going to disappear, the x-axis. So now I'm not even tempted to look at it. That's the point. So when I start at the bottom, notice there's no line, no points. It's just a coordinate plane. So I'm going to move until I run into my first point, which is right here at negative 2 on the y-axis. So negative 2 is where I'm starting. And this is a closed dot here, so we have a bracket. Something else I want to point out. Notice that negative 2 has 2 different points on it. It has this one and this one. A lot of students will look at this curve and think, oh, that's open, there's no closed dot. Reminder, a line is just a bunch of points strung together. So where you have a solid line, you also have solid points. So just because they didn't emphasize this by filling it in right there, doesn't mean that it's an open dot. If it's an open dot, or in other words, a hole in the graph, they will draw it. They have to show you that it's there. So if you don't see this, it is not open, it is closed. It is a bracket. So, just a reminder, both of these mean bracket. So our starting point is negative 2. And then we just go up on the y-axis and see what happens. Notice the graph is continuous. The line is filled in. There are no holes or jumps or gaps. It just keeps going. And I just follow it some more until it stops right here at 7 on the y-axis. So 7 is the highest that it goes on the y-axis. And again, we've got that closed circle and also the straight, not the straight line, but the solid line here. So there's no hole. So again, this is going to be a bracket. So my y values go from negative 2 all the way up to 7. There's no graph outside of that. All right, let's take a look at another example, number 2. Domain moves from left to right, L to R, and it's the x values. So again, I'm going to fill in the infinities as well, just as a constant reminder of where those are at. So I'm going to start on the left side of the graph. Notice with the negative 12. Another way to look at it is if you were to draw a straight line, a vertical line, through each x value, does it hit a graph? That's the question to ask. That's what I'm trying to demonstrate with the post-it note since it's vertically going through. No graph, no graph, no graph. We're hitting graph here at negative 10. So negative 10 is where I'm starting. Now here we have an open dot, otherwise known as a hole in the graph. When we have that, this is when we have a parenthesis. So the graph starts at negative 10 on the x-axis, but it's not actually including negative 10. After negative 10, we're just going to follow it and see what it does. We've got our continuous line here, still going strong, still going strong. Keep following it all the way to where it stops here at positive 10. That's the last sign of the graph. After that, it is gone. So 10 is our ending point, and it is closed dot. It's filled in. So this is a bracket. So 10 is included, negative 10 is not. So those are my range of x values for this function. Now let's do the range. Range, remember we go from bottom to top, b to t, start at the bottom and go up. And range again is your y values. So I'm going to start at the bottom here. Now I'm going to move up the graph and all I'm looking at is the y values. That's what I'm concerned about. I no longer look at the x-axis. So starting at the very bottom, and again, this is like if I were to draw horizontal lines through the graph, which is what I'm demonstrating with the post-it. Does it hit any of the graph, like any points, a line? That's what I'm looking for. So starting from negative 8, negative 7, negative 6, I'm hitting absolutely nothing. It's just blank coordinate plane until I get up to negative 4. Negative 4 is my first sign of a point. I've got a point here. And then I've also got this solid line here. Reminder, that also means it's closed. It's included. So the lowest point here is negative 4, and it gets a bracket. So I'm going to keep following it. I want to stop here because we have a hole in the graph. Usually this is cause for concern. However, and this goes through negative 3. Notice if I follow the negative 3, I hit the line 2 more times. Here and here. Now these are closed because they're just a solid line, so there's a point here. Essentially, when you have a closed dot and an open dot together, essentially the closed dot cancels out the hole in the graph. So it's almost like that hole is not even there. So when we have that, we can just ignore it. Just keep on going, pretend it's not there. So it's continuous. Keep going up. It's a solid line, as it should be. It's continuous. And we get to our stopping point, the very top of the graph at 6. So 6 is the highest that it goes on the y-axis. Reminder, this solid line means that there is a point here. There's a lot of points. But right here, there's a solid point. So 6 gets a bracket. And that's my range. Going to do one more of these types of examples, and then I've got 2 other problems that are a little bit higher level. Domain. We move from left to right. This is the x values. Starting on the left side of the graph, there's nothing over here yet, so I'm going to move to the right until I get to negative 7 is my first point. I've got an open dot on negative 7. Open dot means parenthesis. Then I follow the line. It's straight, well not straight, but it's solid, it's continuous. I'm going to keep following it, it's going to keep going, and it's going to stop at positive 2. That's the last point for the x values. And then the graph stops there. This is an open dot as well, so 2 is also not included in the graph. So this graph includes all the numbers between negative 7 and 2, but it doesn't include either of the numbers themselves. Negative 7 and 2, they're not part of this graph. They're just the start and the stop. All right, that's my domain. Range. It's from bottom to top. Start at the bottom, work your way up. It's our y value. I also forgot about my infinities. I know I'm not going to use them yet, but it is good practice to know where they're at, because when you need them, you're going to need to know where they're at. Range, bottom to top. Start at the bottom of the graph. We're going to work our way up. We're looking to hit a graph or a point or something. we've got nothing, 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 nothing. Negative 4 is where the graph starts for the y values. Again, solid line means there's a point here. So negative 4 has a bracket. It's included. We're going to go up. Notice the hole. Pause for a moment. Be a tad concerned, but then also see that if I go through, it's at negative 2. It also hits here and here. Those are solid points because they're on the line. So the hole, it's like it never existed. Now we go up to negative 1. There's another hole in the graph, but good thing is we've got solid points here. We follow it horizontally. So that hole is covered. We're good. Keep going, and we hit the top of the graph where y equals 1. So 1 is the highest that it goes on the y-axis. And again, this line here means it's like a solid point. So this is included as well. The only time you're going to have that parenthesis is when you have an open dot, which we did for our domain, but they did not matter in the range, or if we have an infinity symbol, which we're going to get to in just a moment. So this is domain and range when we're using actual numbers. Now let's look beyond that. 2 more examples. Number 4. These are the types of graphs you're going to expect to see in Algebra 2 and beyond that. First, infinity symbols. Negatives are on the left, so I've got negative infinity, positives on the right, positive infinity. Negatives are down, so negative infinity down here. Positives go up, so positive infinity up there. Domain. Again, we move from left to right. These are your x values. So we're going to start on the left side of the graph, and we're going to move until we hit something. Nothing, nothing, nothing. We hit an arrow. So I'm going to back up for a moment. This arrow is pointing to the left. I understand it's going up. We're not looking at up right now. We're looking at left or right. It's going to the left, meaning it's going back this way. Since it's an arrow, we understand it's just going to keep going forever and ever and ever, meaning it's eventually going to reach that negative infinity. So actually, the start of my graph is negative infinity on the left because it keeps going that way. And again, it has a parenthesis because it's not a real number. So we took care of that. This graph is here the whole time. We just can't see the rest of it. Keep following it. It's solid. It's good. There's no holes, no gaps. And here is where we end. 3 on the x-axis is the last x value. 3. Reminder, unless they have an open circle here, if it stops here, we are to assume there is a point there. So this is a bracket. That's the domain. Now let's look at the range. Range, we move from bottom to top, B to T. And we're looking at our y values now. So we're focusing on the y-axis. So we're going to move up until we hit something. No graph here yet. Keep going, and at this point, we have hit a point on the x-axis. So for the y-axis, this is 0. We're ignoring that 3. We know it's a 3. We've already written it down. For the y-axis, this point is 0. So 0 is our starting point. And we already discussed this is an actual point. It's not specified that it's open, so it's closed. So this gets a bracket. Now we're going to follow it up. The line continues. It is solid. It is good. No gaps, no holes. We keep going, and we hit that arrow. Now again, you're going to have to really think about this. I understand it looks like it's pointing to the left, which it is, but we're also going to ask, because it can go up and left or down and left. Which way is it going? It's going up and left. It's not going up as fast as it was, but it's still going up. It's going to keep going up. and it's just going to go up even further. What I mean is it is just going to keep going up, 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 all the way to infinity. So infinity is where it's going to max out at. And we have a parenthesis because it's an infinity symbol. That is our range. These are the types of domains and ranges you're going to get used to writing out. I have one more and it addresses another issue. Domain. Again, we move from left to right. That's your x values. Don't forget about your infinities. Left is negative, right is positive. Up is positive, down is negative. Domain, we're going to start at the leftmost side of the graph. First thing I hit is this arrow, so let's take a look at it. This arrow is pointing, it's kind of sideways, but it's going to up and left. It's going to the left. Right now I'm looking from left to right. So I'm focusing on, is it going left or right? It's going left. So that means the graph starts all the way over here. I just can't see it. It starts at negative infinity. So I'm coming from negative infinity. I'm finally getting onto my graph. And then I stop here at negative 8. What makes this different from our other graphs is that I can already see that this is not the last of it. It's going to pick back up down here. So let me pause for a moment and write this down. So we went from negative infinity all the way up to negative 8, and then there was a stop. Reminder, there's no hole here, so we are allowed to say this is a solid dot. It has a bracket. Now, this gap here from negative 8 to negative 4, we call a jump in the graph. So when I kept saying there's no jumps, I literally meant we stop and we jump to another part and we keep going. So we have to find a way to write it so that when we read it, we know that there's a gap here. So I'm going to leave a little space here. I'll show you what that looks like in a moment, but let's continue our journey. So we stop at negative 8 and we jump to negative 4. Not open, so this is a solid dot as well. So leave a little space. Negative 4, bracket because of the solid. Then we follow the line, we keep going, keep going, keep going, and we hit an arrow. This is going up, yes, but also it's going to the right. It's just going to keep going this direction. It's going to move towards positive infinity. It's just going to keep going. Now, there's a proper way to deal with the gap here. There's a symbol I need to show you. It looks like a slightly stretched out U, kind of exaggerated U. This is called the union symbol. So it's literally connecting the two intervals together, and this says, hey, there's a gap in the graph. That's why I'm here. I'm connecting the two pieces together. So just to add a little bit more context, when you have this jump, connect the two parts together with then this exaggerated U, and this is the union symbol. That's all you do. And it's kind of ironic. That's what I kind of did when I showed you this jump here. Connected the two. Kind of looks like that U. Same idea. That's all you have to do to write that. For the last time, range. Range, we move from bottom to top. Start at the bottom and work your way up. Range is your Y values. So we're going to do just that. Start down here. Ignore the extra writing, just focus on the lines on the graph. Moving up, this is blank graph. There's no lines drawn, no points, nothing. Up, 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 and I finally hit some points. Once I hit the x-axis, which is 0 on the y. So right now I'm at 0, and I have these 2 points here. That's where it starts. So at 0, we've already discussed that these are solid points, so 0 has a bracket. Now we're just going to kind of pay attention to both of these lines and see what they do. So we're moving up the y-axis. This one's already kind of disappeared. It's just going that way, so I can't see it anymore, but it's still going. We just can't see it, but it's still going. Let's follow this other one and see where it goes. This one keeps going up. It is solid, just like it should be. It continues, and we hit an arrow. This is going up, and when we go up, we are going towards infinity. So it's just going to keep going. 0 to infinity, and infinity always has that parenthesis. All right, this was, I hope, a really good introduction into domain and range, different examples, how it looks. The more examples you see, the better you'll feel about domain and range. I hope that this is enough to get you through for now, but if you're still struggling with this, or you want some extra help, or you have questions, whatever it may be, please get a hold of me either in person or via email, and I would love to help you out some more with this. Otherwise, I hope you have an awesome day. Bye!